This is Dr. B, and let's have a look at 3 examples of opiates. This one is known as morphine. Here's codeine. And here's heroin. If you take a look at them, we see here we have a phenol, which is an alcohol, whereas here we have a methyl ether. Here, instead of the methyl ether, it is an acetyl group. This would be the most water soluble here. Down here we have an alcohol. I wouldn't call it a phenol, it's not aromatic. Same here, but here it's been converted again into an acetyl group. These two are natural products. This one is synthetic. However, if you wanted to isolate codeine from morphine, I should say synthesize it, you could just react it with a methyl halide to methylate it at this position. However, you could also just isolate it from the opium poppy. That's where this word comes from. Opiates derived from the opium poppy. By derived, I mean they're either present in it naturally, these two are, or synthetically. If you take morphine and you react it with acetic anhydride, it will acetylate that alcohol and you'll get synthetic heroin. Heroin is always synthetic in nature. There is a structure-activity relationship between these three. All three of them are narcotics, powerful narcotics, and that means they're mood-altering. But they get stronger as you go from codeine to heroin, and the side effects can increase as well. If you're trying to come up with some sort of structure-activity relationship, I don't really know if this is where it all comes from, but I do notice that this thing is devoid of hydrophilic functional groups. There's no NHs, there's no OHs. That would make it a greasier substance. And when I think of greasy substances, I think of substances that can get through the blood-brain barrier. That might make this more potent. That could be it. That's just a theory. Okay, historically, for over, my God, 7,000 years, it's been known that the opium poppy contains these substances, and they got used and abused over that period of time, and it was a big deal. It had religious implications, there were wars over it, and now there's lots of legislation over it. So these are, potent substances. In 1805, morphine was isolated, so some devices were available, and some techniques were available, so the alchemists were involved in this. Codeine got isolated in 1832, and heroin has been around since 1874. In terms of their difficulty to synthesize them, well, from scratch, these would be incredibly challenging. Look at the large number of chiral centers, and for that you're typically looking at wedges and hatches here. And also look at all these fused rings with these three-dimensional structures. I view this part here as coming right out of the plane, so this has a very three-dimensional structure. It would be fascinating to make a molecular model and have a look at what it actually comes out like. It's very three-dimensional. So it'd be very hard to make, but very easy to isolate, perhaps all too easy to isolate from the opium poppy. And it's only one step to turn it into heroin. These are known as opiates. They're believed to be strong analgesics, which is good for pain. In fact, this is probably the go-to drug or derivatives that are used for severe pain. Demerol, that's it. When I broke my arm, I took a morphine derivative known as Demerol, and it was injected directly into my bloodstream, and let's just say it was an unforgettable experience. The receptor site is the opioid receptors. That doesn't mean we have evolved to deal with opioids directly. I don't believe so. I'm guessing that these are receptor sites that served other purposes but bind well with these substances, which are strong narcotics and addictive. And in terms of location, they're in the brain, so the substances must be relatively greasy in order to cross the blood-brain barrier. This is a look at 3 different opiates.